Section 6.4 on page 92 to 93 deals with equations with fractions. So you've seen these in Unit 2, and I think you've seen some in Unit 1 as well, but here they are. Remember, we're doing algebra alongside the geometry, so some of these equations will have a geometrical aspect to them. That is to say, there'll be a shape, and there'll be questions with equations within the context of shape. I'll do one within this same video. So let's do some raw equations first, straight into grade C, even question 1. Look at this one. Question 1a, page 92, goes a bit like this. Where should I do it? Right, it says x over 3 minus 1 equals 5. Okay, minus 1, take it over and plus it. You know how to do this. So x divided by 3 equals 5 plus 1 is 6. The 3 is dividing, take it next door and multiply. So x equals 6 times 3, answer 18. Easy peasy. That's A. Let's just go straight to D now. It looks a bit more challenging, but we'll do it. It's 5 times x plus 1 over 3 equals 12. You know how to do this. Take the 3 over and divide. Please note, we have 5x plus 1, one blob, divided by 3, the second blob. So don't even think of trying to subtract the 1 to the other side and take it away from the 12, because we still have to divide by 3 to deal with first. So what have we got? We've got 5x plus 1 equals 3 12s, 36. Take away the 1. 5x is 35. And now dividing by 5, 35 divided by 5 is 7. Right, and by the way, you can use a calculator for this if you get really stuck. Let's just do G. G looks like this. X over 4 plus x over 3 is 7. Lowest common multiple. Smallest denominator of 4 and 3, well, that's going to be 12s, isn't it? So we'll put you out of 12, and we're going to put you out of 12. Well, a quarter, if you take it out of 12, is going to be, let's have a look, multiply by 3. Oops, got that wrong. That should be 3 x's over 12, because, you know, 3 over 12 is 1 quarter, and here we're going to have 4 x's, because 4 over 12 is a third, and here we have a third of an x. Okay, so let's write it over one denominator. We've got 7x over 12 equals 7, multiplied by the 12, so 7x equals 7 12s are 70, 84, and x equals 84 over 7, and x equals, because I'm a coward, I'm going to grab my calculator because I'm allowed to in this unit. 84 divided by 7, there you go, 12. Don't like dividing by 7, it's really not nice. So x is 12. Could do the last one, looks even more tricky. This is 1i. So I've got 5 z's. Please be very careful when you write z. Don't make it look like a 2, because it may baffle you. And if you're given a z in an exam, obviously use the z, but to make sure you present it carefully. Right, lowest common multiple of 9 and 3 is of course 9. No point taking these up to 27s or 18s or anything like that. Just leave it as it is. Right, let's go. So I've got 5z over 9, leave them alone. Multiply this top and bottom by 3, so I've got 3z's over 9, that makes 8. Altogether I've got 8z's divided by 9 is 8. Take the 9 next door. 8z's is 72, 8 9 72. So when I go and divide by 8, I should get an answer of 9, really, shouldn't I? Z is 9, that's done. Now I'm going to go back one page because I've prepared question 3 as well, and I might as well stop after that one, give you a chance to have a breather. Now the reason I've chosen this question, and this is question 6 I believe it is, no, question 3, the reason I've done this is because the wording is very, very tricky, although the maths is quite easy. This will generate an equation based upon that bit of geometry there, this two-dimensional slice of cake, and generate an equation. It will be fractions that are involved, obviously, because these are grade C things, and then we'll solve it. Now David has a large piece of cake. Please note it doesn't say a whole piece of cake. He has a large piece of cake, and this piece of cake has been drawn for us right there. He helps himself to a quarter of it. Now a quarter of this, alright? Once he has taken this, the angle at the centre is reduced to 207. Right, so I've got to take a quarter of this. So if I'm going to take a quarter of that, then let's think very carefully. Then if I take a quarter of the cake, so that part is a quarter, the remaining 3/4 must be that angle there. So here I go. 3/4 of the cake that's still remaining will leave me an angle of 207 degrees. Let's just study that again because it's tricky. He helps himself to 1/4 of the cake. Once he has taken this quarter of the cake, he has 3/4 of the cake left. And the angle at the centre is now being reduced to 207 degrees, when before it was a bigger amount of degrees because he had a full amount of cake. Now, alright, let's just go on with this then. Work out the value of x. So I've got 3/4 times x plus 12 equals 207. Now, I can multiply out by 3/4. It's a bit complicated. Better to do this. Leave the 3 on its own and take the 4 over and multiply, because here if we're dividing the whole thing by 4, take the 4 over next door and multiply. At least we have everything on a common level. There's no division here. We can multiply this out if you want to. So I've got 3x plus 36. And let's ask the machine what 207 times 4 is. Okay, the machine makes it 828. Now take away the 36. That leaves us with, just take it away now, my machine. I've got 792. So x is going to be 792 divided by 3. And we'll talk to that in a minute. So according to this, x is 264 degrees. Let's just think about that. The angle at the centre has been reduced to 207. Quarter has been taken away. I have 3/4 left, 264. So that's what it was before he took a chunk out of it. Alright, so x was 264 plus the extra 12 degrees. That would have been 286 degrees. 276 degrees worth of cake, and that's all right. So what I'm going to do is stop there, and I'll get back to you quite soon.